Hi, it's Dave here, and I'm going to walk through a little sample for infusion rate here for you. Let me share a window here first. I'm going to share Microsoft Word. So hopefully Word will open in a second here. And for most of the infusion rate problems, they all kind of follow the same formula, or same method, I should say. And the method I have, well, there's a couple methods. One is to memorize a formula, plug in the values and rearrange it, or rearrange it then plug in the values, and solve it that way. The method I prefer is dimensional analysis, where you don't have to remember the formula. So if memorization isn't your thing, this method works. The other advantage to dimensional analysis method is you keep the units in, and the units will cancel as necessary or as appropriate. And if you've got the answer in the right unit, it gives you a little sense of confidence as well. So without further ado, I'm going to walk through page 191, example 5. Doctor says 2,500 milliliters of fluid given over 24 hours. IV set is 10 GTT per milliliter. So 10 drops per milliliter. And we need to find flow rate. So there's the data. And I would start by looking at the flow rate and ask yourself, what units would flow rate be in? Typically, flow rate is in drops per unit of time. Now we could choose hours or minutes. The book here has an answer in minutes, which is typical, I think, for manual infusion. I think most pumps would be hours, but we'll go with drops per minute. That's our end goal. We want the unit to be in drops per minute. So we need to multiply a whole bunch of stuff together to end up with a result that gives drops per minute. I'm going to switch over to equation mode here. Hold down alternate and press equals. And so I can put GTT per min, drops per minute. Oops. Is equal to, and now I can look for things I can multiply. So I want GTT on the top, so I should look for something that has GTT in it. And if GTT is in it on top, I'm fine. If it is on the bottom, I need to take the reciprocal. I happen to have this little part here. The IV set is GTT per milliliter. So I can put 10 GTT on top. Divide by per milliliter would be 1 ml. Now I need to multiply by something to get rid of the ml on the bottom. What can I multiply that has ml on top? How about this? 2.5 milliliters of fluid. This would be my volume. Milliliters, and we need per hour or per 24 hours. So I could put in my 24 hours here. I've used this piece of data, this piece of data, and this piece of data. Got GTT on the top. On the left for my answer, I got GTT on top. On the right for the data, I've got minutes on the bottom. I need minutes on the bottom on the right as well. My milliliters and milliliters will cancel. And I'm left with hours on the bottom, so I need to fill in the blanks, or I need to multiply by one more thing. And that one thing needs hours on top to cancel the hours on the bottom. And it needs minutes on the bottom to give minutes on the bottom on the left. So 1 hour is equal to 60 minutes. So now if I dig out my calculator, which I don't have handy, or if I can pause recording. Let's see if there's a pause button. There is. 1 second. Okay, we'll unpause this. And with my calculator out, I multiply 10 by 2500, divide by 24, multiply by 1, which is kind of redundant, and then divide by 60, and I get an answer of 17.3611, 361111, etc. Or we can say approximately 17 drops per minute. Most of these questions should be pretty straightforward as long as you keep track of the units. If you've got scrap paper, you can write it out. And if there's any question after the fact, if you're looking for part marks, the people at the Learning Center can take that scrap paper, scan it, and email it to me. That way you and I can both see, or at least I can give you feedback on any errors I see, and I can also see work that you have done, maybe give you a couple of part marks and adjust the mark after the fact manually if I need to. But long and short is, if you do this out in full on a scrap piece of paper, and you keep the units in, the units should cancel nicely, and you'll be left with the appropriate answer in the appropriate terms. Where things might get a little more challenging is if, like, this is a pretty straightforward example. You've got volume, you've got duration, and you've got your IV set rate. Where things get a little more complicated is where a scenario comes up where either a certain volume has been used up already at the wrong rate, for example, or yeah, I think that was pretty much all of it on the assignment. Any of the assignment questions that were a little more difficult would say you want the medicine to finish at a certain time, but based on the existing rate, it wouldn't finish on time. Let's try this. Let's take this previous example. I know this isn't this example's in the book, but what I'm going to do next isn't. I'm going to modify this, and let's say that a physician comes by and says, oh, I see the previous person set this for 24 hours. It should have been, I don't know, let's say it's half over, and wants it to finish in, say, 8 hours instead of 12. So was part B. Suppose hours later, ups the rate and wants in 8 hours. New rate should use the same sort of information here. We still need to find GTT over minutes. Our set is the same. We still have the same diameter tubing, same bag of saline, same bag of, or same medicine applied to it, etc. So our GTT per milliliter is not going to change. But what is going to change, though, is how much liquid we have remaining and how much time we have remaining. So in this case, that's 12 hours later would be half of our fluid, so we can put in 2,500 milliliters times 1/2, all divided by say 12 hours. We need the time remaining, so let's go, let's say 8 hours are remaining. So we've got the original fluid, half of it's been used up already, we've got half left, and instead of 12 hours remaining, physician wants this to finish in 8. And we still need to multiply by 1 hour over 60 minutes. Minutes is a keyword, or minimum is a keyword in the equation editor, which is why it gives me that box all the time. So now if we multiply this through, go over to my calculator. I get a new rate of 25 drops per minute. And I suppose you could do there are different ways to reword this, so just be careful of the wording. It might say rather than finish in 8 hours, he might say finish, let's say 4 hours early. What would that look like? Now we could look at the remaining time and subtract 12, and that would, or take our, there's 12 hours remaining. He wants to finish 4 hours earlier, so we do 12 minus 4 rather than putting in 8. So just be careful of the wording, read it carefully, and decide whether you need to do a little subtraction either here. The other place you might have to do subtraction is maybe somewhere here. So maybe there was a 3-liter bag of saline, and the physician wanted 2,500 milliliters to be used. You might have to put in, you might have to dump 500 milliliters out. I can't see that being one of the questions on the test, but these are the sort. There's really only the 2 places where you might have a little subtraction, and it's just a matter to read carefully, take your time to fully understand whether it's asking for whether the fluid, there's remaining fluid, remaining time, how much fluid was used so far, how much time was used so far, or any combination of those. Just take your time, think it through. And if you want part marks, make a little note as to which assumption you worked with. Might help clarify. Because if I can see that your math is correct, but the comprehension of the question was off, that's a different problem to correct than if the understanding is correct, but the math is off. So with that, I'll pause our recording here and look at addressing your next question in a moment.